Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over how to do synthetic division. Now this is a procedure that makes polynomial long division a little friendlier. It basically is taking all the variables out of play and we work with the coefficients, and not too bad. The first thing that we need to know is in the denominator, it's got to be a linear factor, so it can't have an x squared or any other power of x other than x to the first. And we would like the coefficient, we need the coefficient of the x term to be 1, which is what we have here. We need to think about rewriting it as x minus some number in here that's the same as x minus -6. That -6 we need when we're doing synthetic division. So the first thing that we do is in a little box in the top row, we put that -6. Then we put all the coefficients for x starting with the term of highest degree, and we want to make sure that we hit every power of x, even the ones that aren't listed. So if this one starts with x cubed, if there was no x squared term, we need to put a 0 in as a placeholder there. But here we don't have to worry about that in this example. We've got 1x cubed, so I'm going to put a 1 next, and that again is my x cubed coefficient. Then I need a coefficient for x squared, which is -5, for x, which was 7, and then the constant term, which was 12. So that all goes in the top row. I'm going to leave some vertical space, and then I'm going to draw a line. Underneath that line is where our answer is going to end up. First thing we do is bring down the leading coefficient as is. So that's going to be a 1. Now we multiply -6 times 1, and we put that result here. -6 times 1 is -6. Write it underneath the next number in the line, -5, and combine those two. -5 plus -6 is -11. That's the 1 is going to be the coefficient of the x squared term in our answer. The -11 is going to be the coefficient of the x term. Let's do it again. Multiply and put the result on underneath the next number. -6 times -11 is +66. 7 plus 66 is 73. And then finally, one more product. -6 times 73 is -438. And 12 plus -438, that's going to give us our remainder, -426. So I always box off the remainder. We started with an x cubed as our largest degree 3 in the numerator. The quotient is going to start 1 degree lower than that. So this 1 goes with x squared, -11 with x, 73 is a constant, and the -426 is the remainder. And so one way we can write our answer is x squared minus 11x plus 73, and then the remainder is -426, so minus 426 over x plus 6. Another way that we write it, though, is by writing the denominator x plus 6 times the quotient, and then we add the remainder to the end of that. So we could write this as the function is x plus 6 times the quotient, x squared minus 11x plus 73. That's the divisor times the quotient, and then plus the remainder, that's -426. So depending on what they're looking for, they may say to write it as f of x times q of x plus r of x, or plus r, or they may just ask for the quotient and remainder, which could be written that way. All right, let's try. I've got a couple more set up for us. X minus 3, 3 is being subtracted, so I'm going to start with a 3. This is degree 4 in the numerator. is I have an x to the fourth term. So its coefficient is 2. How about x cubed? I don't see one. I'm going to put in a 0 as a placeholder for x cubed. X squared I see as -3. X I see as -5. The constant is 9. That's ready to go. Bring down the first number. That means that our quotient is going to start with 2x cubed. 3 times 2 is 6. 0 plus 6 is 6. 3 times 6 is 18. -3 plus 18 is 15. 3 times 15 is 45. -5 plus 45 is 40. And to figure out the remainder, 3 times 40 is 120. 9 plus 120 is 129. So if we were just asked to find the quotient, it's 2x cubed plus, because it doesn't say it's negative, plus 6x squared plus 15x plus 40 plus 129 over x minus 3. If, again, if we were given that numerator as a polynomial function, we may be asked to write this result a little differently, but there is the quotient and the remainder. One last one, and the problem here is that I need the coefficient for x in the denominator to be 1, and it's a 2. So what we can do is factor that 2 out. So this is 4x squared minus 7x minus 15 over 2 times x plus 3 halves. Fractions. Oh well. And then we can divide the 2 into each of the coefficients in the numerator. So this becomes 2x squared minus 7 halves x minus 15 halves all over x plus 3 halves. Now this is in a form that we can do synthetic division. -3 halves is going to go up on top in that box. The coefficients starting with x squared 2, -7 halves, and -15 halves. Bring down the 2. -3 halves times 2. That's -6 halves, or -3. You want to think of the 2 as if it's 2 over 1. -3 halves times 2 is -6 halves, or -3. -6 halves might be better here because I'm about to add it to a fraction that has a denominator of 2. So -7 halves minus 3, I can think of that as minus 6 over 2. That's -13 halves. -3 halves times -13 halves is positive 39 fourths. To combine those two, I need a common denominator. It's going to be 4. So -15 times 2 over 2 times 2 plus 39 over 4. That's -30 over 4 plus 39 over 4. That's 9 fourths. So our remainder is going to be 9 fourths. And the result here is 2x minus 13 halves plus 9 fourths over 2x plus 3. We could also bring that 4 from the 9 fourths down to the denominator. Something like this. 2x minus 13 halves plus 9 over 4 times 2x plus 3. You could even distribute the 4 if you wanted to at that point. But anyway, there is an example where the leading coefficient in the denominator was not 1 and how we handle it. All right, that's it for synthetic division. We'll worry about the polynomial part in the next video.